So today what we're going to be doing is using the law of cosines and the law of sines to solve applications or word problems. And let's take a look at the first problem in the packet that I attached to this assignment. For problem number 1, it says that we have a flagpole located up a slope that makes an angle of 14 degrees with the horizontal. The pole casts a 16-meter shadow up the slope when the angle of elevation of the sun is 20 degrees. Find the height of the flagpole. So let's get started by drawing a picture. Here's the ground. We have a slope of 14 degrees. We have a flagpole that we're trying to figure out the height of. The sun, when it casts a shadow, the shadow is 16 meters. And the sun is said to be at an angle of elevation to the flagpole of 20 degrees. We want to find the height. All right, so that's just the information that we're given. For a lot of these word problems, we use geometry and alternate interior angles. So for example, if I continue out this line, and if that angle is 20, and I draw another line like this, well, I know that if this angle is 20 degrees, then this angle has to be 20 degrees also. They're called corresponding angles. I could slide the upper left of this angle right here up into that spot, and it would be the same angle. So we just drew an extra transversal line or an extra parallel line to figure that out. While also looking at this 14 degrees, this would be an alternate interior angle. So we have corresponding angles of 20, alternate interior angles of 14. So we actually know that this whole angle right here is 34 degrees. Something else that we know is, in order to find the elevation of the sun, this is a 90-degree angle. So if that's a 90-degree angle, and we have the 20, 90 degrees plus 20 is 110, and so this angle would have to be 70 degrees. At this point, we could use law of sines to finish. We would know that 16 meters over the sine of 70 is equal to the height of the flagpole over the sine of 34 degrees. If you cross multiply and divide, you'd get that the height of the flag is 9.5 meters. Let's try number 2. Just keep that in mind. Sometimes we have to draw parallel lines and use corresponding or alternate interior angles. Now for problem number 2, we have a plane that flies 500 millimeters. That's really small. Maybe it should be kilometers, but we'll just go with the wording here. So if plane flies 500 millimeters with a bearing of north, 44 degrees west from B to C. So I'm going to start drawing that right here. We'll start at B, and the way that we figure out bearing is that first number tells us which way we're going first. So north 44 degrees west. So we're going north first and then west 44 degrees. So this is going to be 44 degrees. That's how we start that. From B to point C. I'm going to draw little compass there. The plane then flies southwest 840 kilometers from C to point A. And that's 840 millimeters. And we know that this is 500. That's what we started with. Find the bearing of the flight from C to A. So we're looking to find this number right here. Okay, so let's see what we could do here. I'm going to complete this triangle. And if that's 44 degrees, and this triangle is a right triangle, well, we can't even assume that it's a right angle. But one thing that I do know, I know if that's 44 degrees and this line is parallel to this line, then that means that this angle is 44. Okay, and if that's 44 degrees, then what else do we know? I think we have to assume that this, the return flight, is due east. All right, so I'll make sure that on the test that I put that there. But the flight is making a complete roundabout flight. So if that's 44 degrees, well, actually, we're using a compass, right? So if that's 44 degrees, we know that this angle right here is 46 degrees, just from using the compass. If that's 46 degrees, then this is 46 degrees. And if we were to make a triangle, we have, let's see, we have 46 degrees, 44 degrees, and what else do we know? Well, at this point, we have an opposite length, and we have this angle. So I know that 840 over the sine of 46 would equal 500 over whatever angle A is. So let's see what that comes out to. 500 times the sine of 46 divided by 840, and we're going to be taking the inverse sine of that. Comes out to 25.4. Well, if that angle is 25.4, and we know that that other angle is 46, then we could subtract from 180 to get this whole angle. 25.4 plus 46. We're going to do 180 minus that answer and subtract 44 from that. And we'll get this missing angle right here is 64.6 degrees, which is what we were looking for. So the bearing from C to A is, we're going south and then 64.6 degrees west. The reason why we could assume that this is 46 degrees is because we made a compass. So if one angle is 44, that means that whatever angle is left over here would have to be 46. That was a little hang up there. Okay. All right, so now let's see what else is next. And then we just have problem number 3. Problem number 3, a pilot's just started a glide path for landing at an airport where the length of the runway is 9,000 feet. The angles of depression from the plane to the ends of the runway are 17.5 degrees and 18.8. All right, so let me draw a plane here. All right, it's a good looking plane. And it's approaching a runway. Maybe make this the end of the runway. And I will make this the start of the runway. And it says that the runway is 9,000 feet. All right. And the angles of depression from the plane to the ends of the runway. Okay, so angle of depression. So if that's the horizon, one of the angles is 17.5 degrees. That's going to be this closer one right here, 17.5 degrees. And then the other angle from the horizon to that other angle is going to be 18.8 degrees. So if that whole thing is 18.8 and we already know 17.5, 18.8 minus 17.5 gives us this missing piece of 1.3 degrees. All right, so now that we have all of that information down, let's look to see what we're asked to find. Part A, find the air distance of the plane, or find the air distance the plane must travel until touching down on the near end of the runway. Okay, so if this is the height, this would be the distance that we're looking to figure out for part A. Let me see, find the air distance. The air distance would be this. This is part A. Okay, so the way that we could figure out the air distance, part A, is, well, we know we have, let's see. So if that's 1.3, the height the plane makes with the ground is 90 degrees. So one thing we could do is just start filling in what we know. So we know if that angle is 18.8, if we do 90 minus 18.8, we'd get that this angle is 71.2. So we could figure out this angle by doing 180 minus the 90 from the height, and then minus, let's see, 71.2 and 1.3. So 180 minus 90 minus 71.2 and minus the 1.3 would give us 17.5 degrees. All right, so that helps us because at this point we could do for part A, now that we have that angle, we could do the answer for part A divided by the sine of 17.5, and that's going to equal 9,000 feet divided by the sine of 1.3 degrees. And if we do that, the answer for part A, the air distance, let's see what that is here. So 9,000 times the sine of 17.5 divided by the sine of 1.3 comes out to 119,289.1 feet. All right. So that's how we figure out the air distance. Now let's go to part B. For part B, it's asking us find the ground distance the plane must travel until touching down. That's this part right here. Point B. All right, well, it looks like we have the hypotenuse, right? So we're working off of this triangle. That the answer for part B, we know if this is a 90-degree angle and the hypotenuse 119,289.1, we know that this angle right here is 71.2, then we could use the sine of 71.2 degrees, and that's equal to the answer for part B over the hypotenuse. And if we cross multiply and divide, the answer for part B, the horizontal distance the plane must travel, or the ground distance, is 119,289.1 times the sine of 71.2. And that comes out to 112,924.9 feet. So it's just a matter of filling in some of the missing pieces here. And then part C, the question is find the altitude of the plane when the pilot begins the descent. So that's the height right here. All right, well, again, we could use our triangle that we just set up. If we know that this is 71.2, right angle, and this is 119,289.1, we're looking to find the height. So if we take the tangent, or let's see, we don't even have to use tangent. We could use the cosine. The cosine of 71.2 is equal to the height divided by 119,289.1. Now there are other ways to do this, but I think I did another way on my sheet, but you could, I'm sure you could follow along. So let's see, 119,289.1 times the cosine of 71.2 gives us a height of 38,442.8 feet. That's the answer for part C. Now 1 mile is equal to 5,280 feet. So we could always convert these to miles if need be, but that wasn't something that was asked of us. All right, so for homework, this is what I would like you to do. I would like you to do in the packet please do numbers 7 to 9. Thank you very much, and have a nice day.